In this video, let's understand the difference between simple RAG and agentic RAG. In simple RAG, the user query is first converted into an embedding, searched in a vector database, relevant documents are retrieved, and sent to LLM for final answer. But if a question needs multiple tools, like an API, web search, or another retriever, simple RAG cannot adapt. Unlike simple RAG, agentic RAG plans before it retrieves. A routing agent first understands the user's query and decides whether it needs a retriever, an API, a web search, or a combination of these tools. It only uses what's necessary. Finally, a reasoning agent brings everything together to generate one accurate, coherent answer. So the difference is simple. Simple RAG retrieves once and answers. Agentic RAG plans, chooses tools, reasons across multiple sources, and then answers. Now that we've understood agentic RAG, let's introduce LangGraph. Building agentic workflows means coordinating multiple agents, tools, and decision points, which can quickly become difficult to manage. LangGraph is designed to orchestrate these complex workflows. It provides a structured way to build stateful AI applications using three core concepts: nodes, state, and edges. Let's start with nodes. Nodes are the building blocks of a LangGraph workflow. Each node is responsible for performing a single action or task. For example, one node might act as the routing agent, another might retrieve documents from a vector database, while others can call APIs, perform web searches, or generate the final response. Together, these nodes break a complex workflow into simple, modular, and reusable steps. Think of state as the graph's shared memory. Every node reads from it and writes back to it. For example, the routing agent receives the user query, and based on user query, it stores the next action as API tool in the state. The API node then executes, updates the state with its results, and the workflow continues until the final answer is produced. Think of edges as roads connecting different nodes. They control how information flows through the graph. Here, if the routing agent decides it needs knowledge, the edge guides the workflow to the retrieval tool. Let's see everything working together. For a query like, what do my open tickets mean? The routing agent decides that both the retrieval and API tools are needed. Each tool writes its output to the shared state. Finally, the reasoning agent combines everything in the state to generate one complete answer. That's LangGraph in a nutshell. Nodes perform actions, state stores and shares memory across nodes, and edges control the flow. Together, these three concepts enable AI that can reason, retrieve, route, remember, and act. Now it's time to build our agentic RAG application with LangGraph. We'll start by installing the required packages and configuring our environment before writing any code. Next, we import the required libraries and load our OpenAI model. We then define a valid routes variable containing the three available tools: API, retriever, and web search. The routing agent can only return these tools, ensuring its decision always maps to a valid tool in our workflow. This is our shared graph state for the entire workflow. It stores the user question, the selected route, the outputs from the retriever, API, and web search tools, and finally, the generated answer. Each node reads the fields it needs as input and writes its own output back to the shared state. Next, we create a mock knowledge base that simulates the output of our retriever tool. Since building a full retrieval pipeline isn't the focus of this tutorial, we'll use sample documents stored in a knowledge base variable. Next, we define a mock web index that simulates the output of a web search tool. In production, this data could come from Google Search, Tavily, SERP API, or any other web search API. Here, we'll use sample search results to keep the focus on the agentic RAG workflow. This is our routing agent. It reads the user's question from the shared state and creates a prompt asking the language model to select the tools required to answer it. The model can return one or more tools. We validate model output with our valid routes list, and if the response is invalid, we safely fall back to the retriever before writing the selected routes back to the shared state. Now we create our three tools. Instead of calling real services, each tool returns mock data. The retriever fetches sample documents, The web search tool returns mock search results, and the API tool simulates live API data before updating the shared state. Finally, we implement the reasoning agent. It reads the documents from the retriever, web results from the web search tool, and API data from the API tool, all stored in the shared state. Now we register all the nodes in our graph. Each node is assigned a unique name and mapped to the corresponding function. Whenever LangGraph executes a node, it simply calls the function associated with that node name. Next, we define the fixed edges by specifying the node names to connect. The workflow always starts at the routing agent. Regardless of which tools are executed, their outputs are always passed to the reasoning agent. Once the reasoning agent generates the final answer, the workflow reaches the end node. Now, this is where LangGraph becomes dynamic. The route decision function returns one or more node names stored in the shared state. Add conditional edges uses those node names to determine which nodes to execute, automatically invoking their corresponding functions. If a single node name is returned, only that tool runs. If multiple node names are returned, LangGraph executes all of them in parallel before moving to the reasoning agent. Finally, we compile the graph and invoke it with a user question. LangGraph executes the entire workflow, from routing to reasoning, and returns the final answer from the shared state. And that's the complete implementation of an Agentic RAG application using LangGraph. You can find the full source code in the GitHub repository linked in the description. Thanks for watching.